And let's do the lab. We have left out in lecture 1. I need to do it now because I have seen that some work already involved chunks coming out, if you noticed. So I have to introduce it. So we go back to the slide of lecture 1, and then you come here, slide 63. I go to what you have seen first. So in previous lessons, you have seen something like chunk represented in this way. This is pretty funny. It is produced by a software package called DASK, D-A-S-K here. And this software package is for parallel processing. So here is the computer science stuff. I just want to let you know its feature. It can utilize multiple CPUs. It will divide your data into chunks. And then it will do it internal by itself without you noticing it. The processing of the data can be divided into more than one task. And then for each task, it can schedule the running of each task depending on the dependency between tasks like this. And then according to what needs to be computed independently, say in this example, there are 3 tasks that can be computed independently. So it will assign one task to one CPU core. So you will see that in the Jupyter Notebook, it allocated more than one virtual CPU to you. So this task library can simultaneously assign 3 independent tasks to more than one CPU. When it is executing like that, you will probably see that CPU utilization is more than 100%. That's great because this may be able to speed up the computation, and then after you execute it, you wait for less time. So how can we divide the data from one chunks into more than one chunks? You need to add the argument chunks when you call open data sets. So here you can put a comma and then add more arguments. Here, if you just add chunks, it actually expects a dictionary. So if you want to try it, you just give an empty dictionary and let's see what it becomes. So previously, you haven't seen this. If you add chunks equal to an empty dictionary, then xarray will involve task. And then you will see chunks coming up. And then after you do this, actually you can check the output first. When you use Jupyter Notebook, we often do this. We're not sure what to do. We print something out and then check what we can do in the next step. So in dimensions, you can see there are 3 dimensions. So if you want to break the data into chunks, you choose 1 or 2 dimensions to break it. Here, we try to use the dimension that has the highest number. And then you specify this dimension as a string. Okay, you need to use a quote, single quote or double quote here to specify the name of the dimension. And then colon, and then how large is each chunk? Say you just see that this is more than 1,000, then you tell xarray to cut the data into chunks, each with which have 10 within each chunk. So here there are about 100, and then there will be 15 chunks here, and then that will do the rest for you. And other advantage is that it has lazy computation, and also for big data, such lazy computation, you will see that when you try to print it out, like ds.msl here, if you do not use trunk, you will see you try to go straight, go ahead, print that values out. But if you have used trunk, it actually show you what's arranged in the trunks and the organization of it. It is actually lazy. And if you do not call compute or load or no other task in the downstream requiring the values of them, they just memorize the computation steps, which are to be executed only when needed. This is called lazy evaluation. So it does not need to load all the data into memory when you just mention it. In case the size of the data is larger than the memory, task can do it by only accessing the memory of the chunk it is currently processing without loading other parts of data into memory. So it may be able to avoid the problem of too large footprints and use up all memory and then kernel die. And you just go ahead, try it, and by adding this argument, and when you need it, to see what happens. But if the computation really have very large footprints, then you will see Jupyter kernel still use up memory and it will die. So it basically may extend the capability, but not unlimited.